Alright, this is going to be a very off-the-cuff video, just showing you the process of how I learned programming. So, I'm going to be learning Lua today by making a polynomial root solver. Now, I don't have much experience with Lua. I've only watched a 15-minute video about how to use it. So let's start with what you have to do with every language, which is a hello world. Alright. Now here's how I'm gonna do the root solver. So let me get my pen and paper. My pen over here. So when you have a polynomial, let's make a little graph here. And you wanna find a root. Basically, you're gonna want to take a random guess. So let's say we go over here, and then do a tangent line. I know the tangent line was over here. Anyways, do a tangent line right here. This is Newtonian iteration. Now we see where it hits 0. We go up here, and where it hits 0, we choose that point in the graph, and we draw another tangent line. We repeat the process until we reach close enough to 0. Now obviously there are some caveats, like what if our tangent line is here? Now you have a perfectly flat tangent line, and we won't be going anywhere. Or what if we're stuck in a loop like this? Let's say we kept going between here and here. But let's not worry about that for now. Let's just focus on solving roots. Now, first things first, you gotta figure out how to do I/O in Lua. So, take user input in Lua. Go to Stack Overflow. Start.io. Alright, so let's prompt the user for, let's ask them how degrees. I forgot this isn't C. And we take degrees and go io.read. Alright, now let's print, just to make sure we have it as a number, as 1 plus degrees. Let's say 4. Alright, so it is a number. Did you miss local? I don't know what that means. Let's see. Now we want to read 7. Multiply. Read 7 characters from standard input. Read 2 numbers and assign them to A and B. Alright. How do I do a for loop? So we're gonna need to do a for loop in order to get all the different degrees. Right. For green. This is all right. Let's do what it says. Whoops. And it says Lua has weird syntax. 5, 4, 3, 2, 1. All right, that works. I wonder if it does it like Java. Wait, no, because this doesn't work when it gets to second. Degree. Does it want commas instead of? I wonder why it does that. Why is this space so big? Okay, doesn't matter. Just do a resizable. I wonder if we replace this with 1. Does that work? No. Alright, so it's a negative number. 5, 4, 3, 2. Yeah, that works because you got the 0th. Alright. Nah, there's a space. Alright. We need a table, I think. Yeah, they're called tables in Lua, right? should not stop bothering me. Should replace this with a number of degrees. And local, and we actually call this degrees, equals let's see. Table. Insert degrees. I know it starts at 1. Oh wait, it doesn't matter. Oh. Four. 1, 2, 3, 5. Oh wait. I should have another for loop. Let's see, it should be degrees I. Five, 6, 1, 2. I'm gonna do this just for clarity. Oh. Whoops. 8902. All right. Now for the fun stuff that might be a little harder to get into. So now what we want to do is we want to turn local coefficient of, because we want to take the derivative. spacing is still bothering me though. Alright. So we're gonna be using the power rule for this. Let's just do it in the same as print degrees. So should start at 1. Alright, so the first degree is 5. So if we're doing this right. Oh wait, dang it. Should work though. No, 7. Let's do 3. Okay, yeah, so it does start with the highest degree. Just making sure. Coefficients of derivative. It was table.add, right? Alright. I check. Yeah, okay. It's not table.add. Coefficients of derivative I don't know why they made Lua array start with 1. I'm sorry if I'm not talking that much. That's just the way it is. Alright, so the coefficients is gonna be I. Whoops. What was it? Degrees. Oh wait, no. I was right the first time. Degrees. Yeah. Let's do 3, 4, 5, 8. Why is it 8 times 5? Oh wait. No, yeah. So it is working as intended. So this should be alright. So the first one is 3 is a quadratic, and then okay. What's this? Because it's been bothering. Why is there a space? Actually, how about I just... Yep. With print, in print, let's just say multiple arguments instead. I use a space of print with multiple arguments in the Lua. Alright. Each argument inserts a new line at the end. It is primarily for debugging and a simple tool. If you want a more rigid control, use SD. Well, that's silly. I don't like that. Is there printf and Lua? You'll need a custom function. This is way off topic, but string.format. Alright. Next symbol. Oh yeah. Alright, so yeah, right amount of spaces. And why does it do that? Why does it give you tabs? I get if it was single spaces, but tabs? Kinda weird. Let's see, function. It does a new line automatically, so we can't really do this. Alright, still though. No, we don't need to do that. Okay. Now that we have basically the polynomial and the derivative, we're gonna need to find. How about I inverse the table maybe? Make it right. Because it actually maps on pretty well. Alright. No, yeah, let's flip this. 0 times 4, 2 times what? Degree 3. Was that a bad idea? Because I want the... Maybe I should have kept it for this one instead. Because I want the degrees to match the place in their table. So if I have... So first... Oh, alright. Let's just get rid of this. Why is it saying unused? It's totally used. So the first one is going to be the first degree. Table. We do something like Three is 9. 2 is 8. 2 is... Why do they all say degree for? No, wait. That's why. 6 and 2. Degree 1 is 2. What? Alright, so the first one makes sense. Degree 3 is 2. And shouldn't it just make sure? So you gotta remember that. Let's do alright, since you don't have a lot of code really here. Alright, the first one should be 5th. No, yeah. The first one should be, that's 4, it would be 4 times. Five times. Just doing it backwards. Is it doing it right though? 4 times 6 is... No, 2, 5, 8. What did it say from smallest to largest? Area coefficients from largest to smallest. Chunk 20. And Lua 20, bad arguments, number 3 to format. Yeah, this should be LF if is this right? Not yet, still. Valid conversion -L to for. Why does it have to do tabs though? Two is nil. Why is it nil? Degree 2 is nil. And there's nil, first of all. Since it's a quadratic, it has to be a linear one. Man, I've been spending too much time on this. Man, I really wish Lua array started with 0, you know. Make things easier. But why is it nil though? That's weird. Alright. This one worked, I think. Alright, let's go back. Oops. What the heck? Did I not save? Break coefficient I. Attempt Lua 20. Oh. Yep. Yeah, that was a lucky thing, but it works. try it again this time. With 9, -8, 4. That one should be 18 and -8. Yeah. Alright. Oh yeah, so I guess it starts with the largest degree and ends with the smallest. Okay, I don't think I need this bottom part anymore. Okay, now so now it's time for the fun part, kind of. So if we want to find the coefficient, let's go to Desmos. So you have the function f of x, and let's just write it like -5. Let's just make it a cubic, +1, and with all real roots. Let's keep it like that. Alright. I think it makes it easier to see. Now we have -1, 5, and 9 are roots. Now if we have f prime, prime of x, I'm not really gonna care about this. So if I put if I want a line over here, say I want a tangent line at 5. I want to do, let's do A. Oh. Hold on, I may need to fix my themes. Alright, fixed. So you have A, and then you have f of A. That is going to be the slope at that point. So put the extra parentheses. Alright, so what we want is for this to be kissing this point, or kissing that line. So we find where it is. So if we remember, mx plus b, and in this case m is f prime of a. So let's move this over here. That would equal f of a. So if we want to get b, it'll be f prime minus f of a. I think. No. Was it the other way around? Minus f prime plus. Alright. Let's do this again. F prime of b plus b equals f of a. Now if we multiply this by so we got this is a. So f prime of a times f of a. Alright. Oh. So I got an answer for my calculus homework, or my calculus test wrong. Dang. Alright. So now all we need to do is find when this equals 0. So it'll be f prime of a minus f of a prime of a times a minus f of a all over f prime of a. That's when it equals 0. So we're going to take this thing and make it our new guess. So let's copy this number and put it over here. Oh my god. 1.88. And as we can see, we're getting close enough. This is the last iteration we need to do. Alright, so we need to know what close enough to 0 is. Now obviously we're going to need to do this far. So let's say we have an actual, let's say now we don't know what the things are. Now this function has complex roots, so we might, I don't know if we have time to work on that, on finding complex roots. But as you can see, we're already pretty close, I guess you could say. Alright. So this is gonna be our new A. And we're gonna keep doing this until we find A0. So we're just gonna be looking for 1, 0. So let's do, is there a way to do a const? Local a while loop. Alright, so let's call this closeness to 0. Local. Let's make this, let's do a function. Function Lua. Alright. Function forget. I like to do my functions in Pascal case. Not Pascal case. I don't think that's not what it's called. So we have the original function. Maybe we could do functions, but original polynomial and then the derivative. That's not how Lua does it. Yeah, now you have to do end. Man, curly. I like my curly braces. Alright, so remember the tangent line. What is this? So how do we get? We pick a random number. Let's start with. Let's call this input. So let's do local. Let's do d for the derivative. Local d slope. And then the local. Oh, what should the other thing? What was the other thing? I don't know. Let's do dm instead of db. I don't need semicolons. This language doesn't. Alright, so our first thing is this. So dm that equals our, if we put our input into our thing. So let's do, let's take this, place this over here. Unused, original polynomial. Let's make this global. Global and based on the degrees. Alright, so we start at 1. 1 is the highest. Number of degrees minus 1. Alright. So it'd be number of degrees minus I think. Yeah. Okay, so let's see. E underscore m equals input times time multiplied by number of degrees minus 1. Would it be number of degrees minus 1? I don't I don't know. It'd be yeah, it would. Plus equals. To raise to the was off which is a higher precedence. So this work will need to use POW. Value yeah, it's unused, whatever. Put the polynomial. Crazy. I shouldn't get ahead of myself, but I'm gonna do it anyways. Alright. So it'd be dm now equals d underscore m times input minus d underscore m BDV, sorry. I put too much in this function. I should have done it kind of different. In fact, I'm gonna fix this later. Alright. And then we return a table db. Why does it need 2 dashes? That's weird. What else? Alright, so I just want to make sure I got these right. I'm gonna have to refactor this a little later. So let's print local comma, wait, no. What's efficient such derivatives? No. Was it degrees? Insert to degrees. I need to fix my variable names. Let's see. 0. All right. Now we got a print. Oh, we already have a print statement here. Okay. Tangent line 1. It's 4. -1. 2, 3, -5. Attempt to perform arithmetic on nil value local DB in 38. Alright, so first of all, I did this wrong. Alright. Function. Evaluate. That's how you spell it. Alright. Now, take the input. And this is how you're supposed to write stuff. How long is this video so far? Oh yeah, good thing I'm still recording. Alright, so the way it should work is we take a get n. What is get n? Frequently low, we assume that an array ends just before its nil elements conversion. I have a nil inside an array for example. Set n. Alright, so get n just takes the table defines two functions to manipulate array sizes. Get n, which returns the size of an array, and set n, which sets the size of the array. Alright, so we just need to do table.get n. Alright. Wait, so what are all these? need to do a dot? Or, no. I put it in here. Alright, I'm gonna assume the largest is the polynomial minus 1. Alright. Pow. Is the exponential function. Matrix operators. Nice, that power is replicated. Alright, so this is okay. It's return value. So this is a boring video, isn't it? Okay. How do my polynomials are? So first you gotta take the polynomial index I and multiply it by input to the power of size. Deprecated, defined, and current is true. Oh my gosh. Symbol. Miscorresponding, and I don't think that's. I disagree. Alright. To get the size of a table in Lua. There is no one way, but it might be disappointing using addition or fail. Really? Oh wait, I should just use a for each loop. For each one. Wait, is this really just the hash symbol? Let's see, in the thing. Right, polynomial. We'll do the original one. Degrees and 0. Hmm. 27. We'll attempt to perform arithmetic on nil value. Is it because I didn't assign anything? Then why is there a 0 at the end? Let's do one instead. Um, 5 plus 9 plus 6. Right, that's 20. 20 plus 10. Alright, that's working fine. Let's rename our things. Our redefine local polynomial. Okay, so we know that we can't evaluate. All right. Now if we can try and get the tangent line. So function get tangent line. Oh, I forgot to make this a get repo. All right, so OG. Just F. Keep our things consistent. Input. And I forgot that Lua doesn't use curly braces. Should I live stream? That is. Maybe have a chat so I can actually have a reason to talk. Is it again? Let me go back to Desmos. Let's okay. This time, let's actually name it local. It's actually slope. Let's start at 0. Underscore. Local. What is the M called? Height, I guess? Or I meant the B. Is it B called MX plus B? Oh yeah, it's just the y-intercept. Alright, so intercept start at 0. Wait, no. It actually equals evaluate polynomial underscore polynomial times input minus slope times the input. Damn. This is how I figured out that I got that question on the calculus test wrong. Hopefully the curve is good enough though. Quite silly. Okay, remember that for later. Alright, so here's how we're getting the tangent line. And we're just returning slope, y-intercept. Let's do another function. Maybe we should change all of these to... Nah. That's fine. Find the spaces only. Oh, name. Find 0. I'm like, get 0 from 4. Return. How do you get a 0 from a line? Alright, you get mx plus b equals 0. So that's negative b over m. So f line to divided by 1 multiplied by negative 1. Really? Is it? Alright. At b equals 0. No, yeah. Alright. And now we test it. We should get from this negative 2.25. Alright. Print get 0 from line. Get tangent line. This is so disgusting. From what is it called? Polynomial derivative. And then we put negative. We want negative 1 as our input. Alright. Lua. Oh, wait. I forgot. How big is your polynomial? This one is 4. The first degree 3. That's negative 1, 2, 3, negative 5. And yep. Alright, this works. We're getting somewhere. Alright, so now we just need to know how far away this little guy, this A, is to 0, which is pretty easy. It's just negative A. Or it's literally just A. The absolute value of A, so we don't really... Or is it? Wait, no, it's not A. I think. Is it A? No, it's f of A. Alright. So, we got some const in Lua. There is no constant Lua, but you can use a little to protect. Alright. Whatever. Local. Wait, do I already have one? called closeness to 0. Let's say needed, or minimum closeness to 0. Alright, and now we do a for loop. Alright, but how do we stop these cases when it's the top? Now they're pretty rare, but they're gonna happen. Not most likely, but they might. So if we do, so how about instead of closeness to 0, we have a variable that's max iterations. Alright, now we have a triple, and now we're gonna do a for loop. So for for I equals 1, number of degrees minus 1, do, because that's the amount of let's see, we can do a maximum of 20 iterations. Alright, I just want to know the zeros. Max iterations. Do this. Local roots. Let's say 5,000. Let's just choose 0.0 or 1. predefined input. All right. How do I know? Is there a way to know like when these functions get really big, if when they get too big? For now, I'm just gonna say 3. For now, the input is just gonna be 3. Let's make another function. Function does the whole thing. Alright, and first it takes the polynomials. Yeah, I don't really need to do that. Alright, input will equal get 0 from line, and the line is going to be get tangent line polynomial, the derivative, and the input. Closeness to 0 will be evaluate polynomial at input. Nope. What was it? Oh. Let's see. Alright. Absolute function Lua. Nice. It's just if no, I don't like this. We should do it here. Math.abs evaluate polynomial. Then we take the original polynomial and then we put the input we got, right? Our input again is A. Maybe we should change it to I don't know. Wait, why am I putting this here? Break. Actually, maybe we should do a random. Function rule. And put the input outside here. Generating random numbers in rule. You need to run math or random C before once easy. Alright, so let's put this at the start. Does this say Lua? Yeah. Does it change it every time you call math.random? Yeah, just to be safe. Wait, but how do I... Because I want one that, yeah. Let's do from -10 to 10. This guy tells us to do OS clock, so I guess I'll do that. I feel like floats might not be that big. Or integers. No, they are. Alright. Doesn't matter. Print. And then input. Alright. Let's see if it works. Whoops. Has no one bad argument to random seed. Number has no integer representation. What is up with computers and randomness? Best way to generate. I love these best way to generate whatevers. As the pig said, using notice time. Alright, I'll use time. Well, let's go back to my Desmos. How big is my polynomial? 4. -1. 2, 3, -5. Alright, 2.337. And alright. So it's got the same number twice. See, this is what I was afraid of. So far so good though. Huh? Eh? Alright, let's see. Let's see what we could do. What I do want to know if there's a way to figure out how, like, the boundary of where the zeros are gonna be of the polynomial. So look, if we run this again, we might actually, we're lucky. See, alright, so this time we actually got this one here. Okay. Let's see. Domain of polynomials. Frequency. I'm happy with this for now. Keep in mind. Roots of a polynomial in an integer, let R be a ring. Oh my god. I already don't know this. This guy's talking about. This is the fact that commutative ring identity is an element. You have a polynomial if and only if some polynomial. Man. Should we watch this or will it get copyright stricken? Oh, these are YouTubes. Alright. Again, 1010 is not gonna be a an exactly big thing. So I think this is we're gonna keep it at this for now. Maybe I'll update it. For now, I'll put it on GitHub or something. That's it.